to 58 minus 63. That gives me 5, negative 5. So I get a common difference of negative 5 when I do those two. Let's take another one. D is equal to 53 minus 58. D is equal to negative 5. So because these two are the same right here, that's proof that we have an arithmetic sequence. That's proof that we have an arithmetic sequence right here, because we found a common difference that was consistent throughout that sequence. Alright, so we have our common difference. Do we have our first term? Hey, there's our first term right there. So, prove that it's arithmetic. Done. Find U1 and D. Here's U1, here's D. Done. Find the 37th term. How do I find the 37th term? Well, I have my handy-dandy calculating device right over here. I'm going to go 37. Boom, negative 117. So U of 37 is negative 117. Okay, so let's take the same concept now and let's expand on it just a little bit. Because now we have to find the first term that is less than negative 200. So this is just a snazzy way of writing out set U sub n equal to negative 200. So if I say U sub n is equal to, I'm just copying the equation here, 68 minus 5n, and I'm looking for when is it less than negative 200. What term number is that? I'm looking for just a term number this time. I'm not looking for a U sub 35 or a particular term value. I'm looking for where in the sequence does this number fall. So that means that this U sub n becomes negative 200, 68 minus 5n. I want to know, when does this equal negative 200? At what n value does it happen? So let's figure it out. Negative 200 equals, so I'm going to do minus 68, negative 5n. So that gives us negative 268 is equal to negative 5n. We divide by negative 5, and 268. It gives us 53.6 is equal to n. Now, you can't have a 53.6 term. So would it be 54 or would it be 53? Yeah, let's check. Let's use our calculator to check, right? If we're unsure as to where it's going to be, let's use our handy-dandy calculator. So, if I'm at 53, I'm not below 200 yet. But if I go to 54, now I'm at negative 202. So we are going to round up here. We're going to say 54 equals n. So the first term that is less than negative 200 is the 54th term, because that gives us negative 202. Any questions on that? Okay, good. Let's move on. All right. So here's number 4. For the sequence 24, 23 and a quarter, 22 and a half, ... negative 36. Let me ask a question here. Is this a finite or an infinite sequence? Finite. How do I know it's finite? Yeah, it has a last number. It has negative 36 as the last number. So even though it has that ... that ... just means that you don't know how many terms there are between 22 and a half and negative 36. It wants to know how many terms are in this sequence. So what's the last term in this sequence? So I know the last term is negative 36, and I need to figure out what is the n. What term number is that negative 36? Well, we're not given an equation here. Are we told if it's a geometric or arithmetic sequence? No, but we can figure it out, right? And you always want to figure this stuff out using a calculator if possible, because subtracting 23.25 from 24 in your head, which is what you're going to want to do, might be a little bit trickier. And there's definitely going to be some nasty fractions on the test. So just go ahead and understand that when you see a sequence like this, don't try to do all this stuff in your head. Just go ahead and use a calculator and subtract any term, any previous term from that current term. So we have 23.25 minus 24. I get a 0.75. So if I subtract this, if I subtract 22 and 23 and a quarter, 22 and a half and 23 and a quarter, I should get negative 0.75 again. So 22.5 minus 23.25, I get negative 75. Fantastic. That tells me that my common difference is going to be equal to negative 0.75, or negative 3/4. So I know that D is negative 3/4. Do I know what A sub 1 is?
Yeah.
It's 24. Do I know whether it's arithmetic or geometric? I know it's arithmetic because I just proved it had a common difference, and only arithmetic sequences have common differences. So let's keep going here, and let's write out our nth term equation. A sub n, and this is for an arithmetic sequence. For an arithmetic sequence, A sub n is equal to A sub 1 plus n minus 1d. So if I had to write this nth term equation, I would end up with 24 plus n minus 1 times negative 3/4. So there's my nth term equation. Alright, so remember where our objective was here. Our objective is to figure out what term number is that negative 36. So what am I going to do now? Exactly right. A sub n is going to be 36. So 36 is equal to 24 plus n minus 1 negative 36. There you go. Negative 36 plus n minus 1 times negative 3/4. Right there. So I'm going to move the 24 over, and that should give me negative 60 is equal to n minus 1 times negative 3/4. I'm going to divide by negative 3/4. That's the same thing as multiplying by negative 4/3. So negative 4/3 right there. Those cancel. Those cancel. I'm left with negative 80. Oh, I'm sorry, positive 80. Positive 80 equals n minus 1. 81 equals n. So what term number is this? It's the 81st term. Are there any questions on that so far? This is a very classic problem. You're going to see a problem like this.
So, if negative 36 is the 81st term, you said it's finite. What's the last term? The total number of terms?
Yes. 81 is the last term. Rather, 81 is the last term number. The value of that just happens to be negative 36. Okay. So we figured out how many terms there are in the sequence. Check. Find the value of U35. In other words, the 35th term. What's the value of the 35th term? Well, to solve that, we're going to need to know the nth term equation. Oh, lucky for us, we already wrote that. Negative 3/4. So I'm looking for A sub 35. 24 plus 35 minus 1 times negative 3/4. Let's not overtax our brains too much. It's getting towards the end of the year, so let's use our handy-dandy calculating device here. And I'm going to say 24 plus 34 times 0.75. Oh. All right, so 24, 34, negative 0.75. Hey, negative 1.5. So U, or A sub 35, is equal to negative 1.5. So find the value U35. Done. The sum of the terms of the sequence. Now this one gets into things that are a little bit different from what we were doing before. And if you have your notes from a while back, now would be the time to get those notes out.
You're not going to be able to use the notes on the test, though.
No, you will not be allowed to use the notes on the test. I will provide you with all the equations.
With them labeled?
With them labeled? Sure, I'll label them. Why not?
So you'll be like, sum of arithmetic sequence, and you'll give us the equation?
Sure. So we're trying to figure out what the sum of all of these terms are. So if I add up all of the terms, in other words, all 81 terms, what am I going to end up with? What does that sum look like? And can somebody read that equation out to me? It says the sum of an arithmetic sequence, a finite arithmetic sequence, A1 plus AN over 2. That's it. Fabulous. So, in our case, what is N equal to?
81.
N is equal to 81. What is A sub N equal to? Negative 36. And what is A sub 1 equal to?
24.
So I'm sorry? 24. 24. So I have all of the pieces to my equation, so I can say that the sum of the first 81 terms of this sequence, right, the sum of the first 81 terms is equal to 81 times 24 plus negative 36 divided by 2. So let's take our handy-dandy calculating device. 81 times 24 minus 36 equals, divided by 2. The sum of the first 81 terms is equal to negative 486. Any questions so far?